double angle and half angle formula. So first we are interested in deriving the formula for sine 2 theta. Sine 2 theta. Okay? We can use the formula that we learned before, considering that sine 2 theta is nothing else but sine theta plus theta. And then if we apply the sum formulae, we can clearly see that sine alpha plus beta, that would be one of those angles is my alpha, one of my angles is alpha, one would be beta, and I can apply this sine alpha plus beta formula. So in that case I would have sine alpha, my alpha is theta, cos beta, beta is theta, my beta is theta. Then we have plus cos alpha is theta, sine beta is theta. And then I can rearrange them. I can switch the order. Cos times sine is the same as sine times cos. So this is equal to sine theta cos theta plus sine theta cos theta, because sine times cos is the same as cos times sine is the same as sine times cos. Okay, and then this is the same term, sine theta cos theta, sine theta plus cos theta. This is the same as x plus x gives me 2x. So this would be 2 sine theta cos theta. So we had the first formula. We had the first formula that sine 2 theta is equal to 2 sine theta cos theta. The same way we can derive the formula for cos 2 theta. We can consider that cos theta plus theta. And then I can use the formula that we have here, cos alpha plus beta. The first would be my alpha, this would be my beta. So I'm gonna use the first formula. So I have cos alpha, which is cos theta, cos beta, my beta is theta. Then I have minus sine alpha, which is my theta, and sine beta, which is my theta. Cos times cos is cos squared, so this one is equal to cos squared theta. Sine times sine is sine squared minus sine squared theta. So that's the second formula that we are getting, that cos 2 theta is equal to cos squared theta minus sine squared theta. So those are the formulae that we just get. Cos 2 theta is equal to 2 cos 2 theta is cos squared theta minus sine squared theta, and sine 2 theta is 2 sine theta cos theta. Okay, now cos theta can have different forms. Cos theta can have different forms. We can substitute. We do know that we have trigonometric identity, trigonometric 1. What that means, that sine squared theta plus cos squared theta is 1. Okay, from this I can substitute for sine or for cos. So if I substitute, first solve it for cos, bring this sine over, so I have that cos squared theta is equal to 1, bring this over, minus sine squared theta. And now I would substitute this for cos to my formula. This cos and this cos I can substitute, right? So I will have that cos 2 theta. I'm gonna have that cos 2 theta is equal to, I'm substituting for cos square, 1 minus sine square theta. That was in my formula, and now I have minus sine square theta. Minus sine and minus sine, like minus x and minus x, gives me minus 2x. So I'm getting that this is 1 minus sine 2 sine square theta. And that's the other formula for cos 2 theta. And similarly, we can use the same trigonometric identity and solve it this time for sine square. If I solve for sine square from this one, I'm getting that sine square theta would be equal 1, and bring this over, 1 minus cos square theta. And this time I would substitute for sine square. So I'm getting cos 2 theta is equal to cos square minus, put in the bracket, and your sine square is right here, sine square, I'm gonna substitute this part. So this one is 1 minus cos square theta. You do need to put the bracket because we do need to distribute the minus. So if we work this out, this is equal to cos square theta minus 1 minus minus gives me plus cos square theta. Collect like terms, 1 cos square gives me 2 of them. So this gives me 2 cos square theta minus 1. And that's the second formula for cos 2 theta. So we had those two formulae. For cos 2 theta. Sine 2 theta is 2 sine cos. Cos 2 theta is cos square minus sine square. You can either remember just this part and always be able to substitute as we did to get the other parts, or you just keep in mind those two. Those are two different variation of the cos 2 theta formula. 1 minus 2 sine square and 2 cos square minus 1. And then we have another tangent 2 theta. Tangent 2 theta is equal to 2 tangent theta minus tangent square. And how did we get this? We will get this exactly the same as we derived the first two formulae. So we would use the tangent theta plus theta and calculate this together. Okay, theta would give me this 2, and then I would have minus 1 tangent square. Okay, now we would like to talk about half angle formulae. So those are the basic double angle. They call it double angle, angle is double. Now we would like to talk about half angle formulae. So I'm gonna use half angle formulae. I'm gonna use those two. Actually for sine theta. So first I'm gonna use this formula. Okay, let's solve for sine theta from this equation. So let's bring the sine square over. So I have 2 sine square theta is equal to 1, and let's bring this cos 2 theta over, minus cos 2 theta. Let's divide by 2. We are solving for sine. Let's divide by 2. So I have sine square theta 2 is equal to 1 minus cos 2 theta over 2. This and this cancel out. So I have that sine square theta is equal to 1 minus cos 2 theta over 2. And now take square root to get sine. Take square root. Whenever we take square root, we need to write plus or minus. So now I have sine theta is equal to plus or minus square root of 1 minus cos 2 theta over 2. And now, if you think we would like to have half angle, so now for my theta, I will substitute half theta. This one would be half theta. If my theta is half theta, then this would be half theta as well, right? Half theta. I just switch. I substitute that theta is equal to 1/2 theta, or theta over 2. And then my formula becomes sine theta over 2 is equal to plus or minus square root 1 minus cos, and what we have right here, I would have cos of 2 times theta over 2, and this one actually is everything in the cos. Okay, so this 2 and 2 cancel out, so I'm getting cos theta. Okay, when I substitute this half theta over 2 times 2 gives me just 1 theta. So I'm getting that this one is equal to theta over 2. And that's the half angle. That's the half angle formula. That's the half angle formula. And plus or minus we choose depends on the quadrant where your half theta is. Exactly the same way we can derive the formula for half theta using the cos. Solve for cos from this one, rearrange the formula, and we get the other formula. So we have the half angle formulae. We have half angle formulae. Okay, that sine theta over 2 is plus or minus square root of 1 minus cos theta. Cos theta over 2 is equal to plus or minus square root of 1 plus cos theta over 2. And tangent is plus or minus 1 minus cos theta, 1 plus cos theta. We get this tangent, half theta is nothing else but sine over cos. So if you divide those two and then divide by a fraction means multiply by its reciprocal, flip this over, you get this formula. And plus or minus sine is determined by the quadrant of theta over 2. And now we have examples. Find the exact values. Find the exact value of sine 2 theta, cos 2 theta, sine theta over 2, and cos theta over 2, if the first case we have that sine theta is 4/5 and theta is between 0 and pi over 2. So from this information between 0 and pi over 2, we know from this information, we know that theta is in what quadrant? 0, half pi 90 degree is pi over 2. So my theta is in the first quadrant. Okay, theta is in the first quadrant. So then I would need, for sine 2 theta, I would need cosine. So I'm gonna draw the triangle to find the value of cos. I put theta. We know that sine is opposite over hypotenuse. opposite over hypotenuse. So this one is 4, this one is 5, hypotenuse. This one is 5. It's opposite over hypotenuse. Okay, that's opposite over hypotenuse. So now we do need to find this x. Let's say it x. Using Pythagorean theorem, we can set up equation x squared plus 4 squared is equal to 5 squared. X squared plus 4 squared is equal to 5 squared. So now we can solve it. And we are getting that x squared plus 16 is equal to 25. Bring this over. So x squared is equal to 25 minus 16. 25 minus 16 is 9. So x is equal to plus or minus square root of 9, which is plus or minus 3. And because we are in the first quadrant, we are choosing 3. So this one, x is 3. X is 3. Okay, so now we are using the formula for double angle. Double angle formula. We need to find a sine 2 theta. Sine 2 theta we know is 2 sine theta cos theta. So now I can substitute. Oh, I should have found this sine theta as cos theta. From this one we have that the sine theta is 4/5 and cos theta from this triangle is adjacent over hypotenuse, so it's 3/5. And all of them are in the first quadrant, so they have positive values. They are all positive value. So in that case, I substitute them to this formula, and I'm getting that sine 2 theta is equal to 2 times sine theta is 4/5 times cos theta is 3/5. I multiply them. This is like over 1. So then I have 2 times 4 is 8, times 3 is 24, and 5 times 5 is 25. So sine 2 theta is 24 over 25. Similar way I'm doing B. Cos 2 theta. From double angle formula, we know that this one is cos square theta minus sine square theta. So if I substitute my values, cos 2 theta is equal to sine cos square, so I have 3/5 square it, minus sine square is 4/5 and square it. So perform the operation. What we are getting is 3/5 square it is 3/5 times 3/5 gives me 9/25. 9/25. So I'm getting 9 over 25 minus 16 over 25. So my value is minus 7 over 25. Okay. So we have negative value, and this is correct. Why? Because if theta is in the first quadrant, now 2 theta, when you double it, they would be in the second quadrant, right? In the first quadrant you have like 40 degree, times 2 would be 80 degree, so that would give you in the second quadrant. And in second quadrant, we know that cosine is negative, because as the story goes, add sugar to coffee, that's only sine is positive in the second quadrant. So cos 2 theta is negative. Now we need to do C, half angle, C sine theta over 2, sine theta over 2. From the half angle formulae, we know that this is plus or minus square root of 1 minus cos theta over 2. Now I substitute the values. Sine theta over 2 is equal to, we choose plus or minus, depends on the angle of half theta, this angle where it is. If my theta is in the first quadrant, let's say 40 degree, half of that would be 20, it's still in the first quadrant. And in the first quadrant, sine is positive, so I'm choosing plus. So I would have plus, we don't need to write that plus. So then I have 1 minus cos theta is 3/2 all over 2. We need to find common denominator. This one is like 1 over 1. Common denominator will be 5. So we need to multiply times 5 times 5. And what we are getting, square root of 5 minus 3 is 2/5, and divide by 2. To divide by 2 is like 2 over 1, so I'm gonna flip this one. I have square root of 2/5 times 1/2. 2 and 2 cancel out. Two and 2 cancel out, so I'm getting square root of 1/5. So this is equal to square root of 1/5. And now we have cos 2 theta, cos half of the theta, d. We need to do d. So we have d cos theta over 2, half theta. I'm using the formula plus or minus square root of 1 plus cos theta over 2. Half theta is in the first quadrant because the theta is in the first quadrant, so we will have plus. So my cos theta over 2 is equal to plus, so square root of 1 plus cos theta. Cos theta is 3/2 over 2. 1 is like 1 over 1. We need to find common denominator as before. Times 5 and times 5. So we will have 5 plus 3 is 8 over 5 and all over 2. 2 is like 2 over 1. To divide by a fraction means multiply by its reciprocal. So this one is 8/5 times 1/2. Nothing to reduce. We can reduce 8 and 2. Reduces to 4. So the final answer gives me square root of 4/5. One more example. We would like to find the exact values of the same 2 theta. Find the exact value of 2 theta sine 2 theta, cos 2 theta, sine half theta. And we have example number 2. If we know that cos theta is equal to minus root 5 over 3, and theta this time is less than theta and less between half pi and pi. So in that case, between half pi, if I draw my diagram from 0 to half pi, we are right here. From half pi up to here, it's pi. So we are in the second quadrant. In the second quadrant, as we go with the story, add sugar to coffee. In the second quadrant, only sine is positive, cos is negative. So we will need the sine value. I draw my triangle, I put theta. We know that cos is adjacent over hypotenuse. So adjacent is root 5, hypotenuse is 3. I do not worry about the minus. Minus I will choose according to quadrant. Okay? So then I would put that this is my y, and then I have, using Pythagorean theorem, we have that y squared plus square root of 5 square root is equal to 3 square root. So we have y squared plus square root and square cancel out. 5 is equal to 9. Bring this over. So y squared is equal to 9 minus 5 gives me 4. So y is equal to plus or minus square root of 4, which is plus or minus 2. We will choose plus because sine is positive, so y is 2. So now cos we have the value, and sine we will need sine theta is opposite over hypotenuse. So in that case it's gonna be 2 over 3. Okay, and its cos sine is positive because we are in the second quadrant, and cos is negative, so here should be minus actually. Okay, so now we can find this sine 2 theta. Sine 2 theta, sine 2 theta, we are using the double angle formula, is 2 sine theta cos theta. And now we can substitute the values. So we have that my sine 2 theta is 2 times sine is 2/3, times cos is minus root 5 over 3, and multiply everything out. This is like over 1. So we have 2 times 2 is 4, times minus root 5, it's 4 root 5. And 1 times 3 is 9. So that's my value for sine 2 theta. And then I'm finding b, cos 2 theta. Using the formula for double angle, cos 2 theta is cos squared minus sine squared theta. So now we can substitute that cos 2 theta is equal to cos, my cos value was minus root 5 over 3 square root. And then we have minus sine 2/3 and square root because we have squared. So this gives me minus root 5 times minus root 5 is positive 5. It would be root of 25 over 9 minus 4 9s. So this gives me 5 minus 4 is just 1, 9. And this, if you need refreshment, minus root 5 over 3. Minus root 5 over 3 square root is minus root 5 over 3 times minus root 5 over 3. Minus minus gives me plus. Root 5 times root 5 gives me root 25 over 9. And then I have, so this one is 5 nines. That's how I got 5 nines. Okay, now we would like to find C sine theta over 2. So C, I'm using the sine theta over 2 formula. Theta sine theta over 2 is plus or minus square root of 1 minus cos theta over 2. The plus or minus we are choosing according to what quadrant is my half theta. So my original theta is in the second quadrant, let's say more than 90 degrees, right? Let's say 100. If you divide by 2, 100, you would have 50. 50 is in the first quadrant. So if you have any angle in the second quadrant and then divide by 2, you would be in the first quadrant. So in the first quadrant, all functions are positive, so we are choosing plus. Okay, so for my sine theta over 2 is, we will have plus 1 minus cos theta is minus root 5 over 3 over 2. Minus minus gives me plus, and we can find common denominator. This is like over 1. So I have 1 and 3. 1 and 3. Common denominator times 3 times 3. So this is equal to square root of 3 minus minus gives me plus root of 5 all over common denominator 3, and then I have over 2. Over 2 is like 2 over 1. To divide by a fraction means multiply by its reciprocal. So this is equal to square root of 3 plus root 5 over 3 times, flip the fraction, 1/2. So this one times what anything else is that anything else. So I have 3 plus root 5 over 6. Okay, now we would like to find CD cos 2 theta. Cos 2 theta. So we have D, not 2 theta, cos theta over 2. From the formula we get that this is plus or minus 1 plus cos theta over 2. And we know that the half angle will be in the first quadrant. Cos is positive, so we are choosing plus. So cos theta over 2 is square root of 1 plus minus root 5 over 3 over 2. I substituted cos theta. So this is equal to, we do need to find common denominator as before. It's 1 is like 1 over 1. Common denominator of 1 and 3 is 3 times 3 times 3. So this gives me square root of, we have 3 plus and minus gives me minus, so minus root 5 over 3 and all over 2. 2 is like 2 over 1. To divide by a fraction means multiply by its reciprocal. So this is equal to square root of 3 minus root 5 over 3 times 1/2. So the final answer is square root of 3 minus root 5 over 6. That's cos half angle. Now we have example 2. Now we have example 2. Use the half angle formula to find the exact value. To find the exact value of sine 15. To find the exact value of sine 15. Okay, half angle formula were those ones. So we have sine, if this one is sine half angle, so what would be my angle? If 15 is half angle, what is my angle? My angle is nothing else but 30, because if theta is 30, half of that is 15. So in that case, sine 15 is equal to, in the formula we have plus minus, we will talk this about plus minus in 1 minute, and then I have 1 minus cos of my whole angle. Half is 15, what is my whole angle? It's 30 over 2. And now we are choosing plus or minus depending where my half angle is. 15 is in the first quadrant. In the first quadrant all of them are positive, so the value is plus. If you draw 15, it's right here, so this one is all first quadrant, and add sugar to coffee, all of them are positive, so sine is positive. And now we do need to solve it. So we need to know the value of cos 30 degree. Make your chart. Cos 30 degree. Cos 30 degree is root 3 over 2. From the chart that it's easy to make. Root 3 over 2. So this is equal to square root of 1 minus root 3 over 2, and then we have over 2. We find the common denominator. This one is like over 1. Common denominator of 1 and 2 is 2, so times 2 times 2. So that gives me square root of 2 minus root 3 over 2 and over 2. I have over 2 from the first fraction and then over 2 from the second fraction. So over 2 is like 2 over 1. To divide by a fraction means multiply by its reciprocal. So this one is 2 minus root 3 over 2 times 1/2. Okay, so this gives me square root of 2 minus root 3 over 4. So sine 15 is equal to this value. Example B. Find the exact value using the half angle formulae. So in that case I have secant pi over 8. If I look into my half angle formulae, I don't have secant, so we need to change secant. We know that secant is what? Is 1 over cos. So this one is 1 over cos pi over 8. So we will go back to this. We're gonna use cos pi over 8. So I'm gonna find the cos pi over 8. I'm using the curly lines. That's my on a side calculation because I need to go back and then write 1 over. Okay, cos pi over 8. I'm using the half angle formula. If pi over 8 is my half angle, what is my angle? So it works like this. It works like this. That pi over 8 pi over 8 is nothing else but half angle theta over 2. So what is theta? We can easily solve it. Multiply both sides times 2. We can multiply both sides times 2. Pi over 8 2 times is equal to theta over 2 times 2. This, when I cancel out, so I would have that my theta is, this is like 2 over 1. So 2 and 8 reduces to 4. So I have pi over 4. If my pi over 8 is half angle, my angle is twice as much as pi over 8. Twice as much, which is 2/8. That means it's 1/4. Okay, so theta is 1/4. Now I can use the formula. Now I can use the formula for half angle, that cos theta over 2 is plus or minus 1 plus cos over 2, square root of 1 plus cos theta over 2. So plus or minus, we are choosing, depends where the pi over 8 is. Pi over 8 is a fraction less than half, so it's in the first quadrant. We are choosing plus. So we will have 1, we'll have plus square root of 1 plus cos theta. What is my theta? My theta is pi over 4, all over 2. So always ask yourself, if the question says use half angle formulae, so pi over 8 is nothing else but my half angle, because I'm gonna use the half angle formulae. What is theta? Pi over 8 is theta over 2. What is your whole angle? Whole angle would be twice as big as your half, which is twice pi over 8, which is 1/8 times 2 gives me 1/4, and that's why I have 1/4. Okay, and the rest we are solving using the chart. Now we can solve it using 1 plus cos pi over 4. From the chart we know, that cos pi over 4 is root 2 over 2. So this is equal to 1 plus cos pi over 4 is root 2 over 2, and everything is all over 2. And as before, we do need to find common denominator. This is like over 1. Common denominator is times 2 is 2. So on the top I will have 2 plus root 2. 2 plus root 2. Then I have over this 2 and over this 2. The 2 is like over 1. To divide by a fraction means multiply by its reciprocal. So this is equal to 2 plus root 2 over 2 times 1 over 2. And this gives me 2 plus root 2 over 4 and square root. And we can rewrite this in different form. We can write this, separate the root. This is square root of 2 plus root 2 over root of 4. When it's multiplication, you can separate. When it's addition, you cannot. So this gives me root 2 plus root 2, square root of 2 plus root 2 over 2. Why did I do this? Because I'm not done with the question. I just found that cos pi over 8 is this value. Now I need to write 1 over. So my secant pi over 8 is 1 over cos pi over 8, which is this value, root 2 plus root 2 over 2. And to divide by a fraction means multiply by its reciprocal. So we do need to flip it, root 2 plus root 2. So this gives me 2 over square root 2 plus root 2. And that's my final answer. Now we have example 3. We use the double angle and half angle formulae to establish identities. The first one is cos to the 4 minus sine to the 4 is equal to cos to theta. To establish identities means prove it from left side to right side or from right side to left side. So we're gonna start from the left side. Left side, cos to the 4 of theta minus sine to the 4 of theta. I can write this as square. I would like to write that this is cos square theta and square it, minus sine square theta and square it. Can we write like this? Yes, we can, because square we multiply exponents, so 2 times 2 would be 4. And now I would think that this is my a square minus b square. How can we factor this? A square minus b square. We had the formula a square minus b square can be factored that this is a minus b, a plus b. My a is cos square and my b is sine square. Okay, so we can write this one. This my cos square, sine square, cos square, sine square. Okay, so I'm gonna write this, that this is equal to cos squared minus sine squared times cos squared plus sine squared. I have this square because I have double squared. Normally I have one squared, then I don't have those ones. Okay, now I'm using this trigonometric identity that cos square plus sine square or sine square plus cos square is 1. We are using these two formulae. Sine square plus cos square of the same angle is 1. And in other we're gonna use this double angle that cos 2 theta is cos square theta minus sine square theta. I'm using those two formulae. So this is equal to, this one is cos squared, nothing else but cos 2 theta, times, and the second bracket is 1. So this gives me cos 2 theta, and that gives me my right side. So the identity is established. Example B. We have cos 2 theta over 1 plus sine 2 theta is equal to cotangent theta minus 1 over cotangent theta plus 1. I'm using the double angle formulae. So I'm gonna start from the left side, that cos 2 theta over 1 plus sine 2 theta. I will substitute my formulae. For cos 2 theta, I have cos square theta minus sine square theta. On the bottom I have 1 plus cos 2 theta is 2 sine theta cos theta. Okay, And now we would like to, first on the top I have a square minus b square. A square minus b square is a minus b, a plus b. So this we can write that this one is cos theta minus sine theta times cos theta plus sine theta. All over, and on the bottom instead of 1 I will write sine square plus cos square is 1. So we have sine square theta plus cos square theta, and then I have plus this, the rest, plus 2 sine theta cos theta. So what we have on top, I have cos theta minus sine theta, and then I have cos theta plus sine theta, and on the bottom I would like to rearrange this a little bit different. I'm gonna write sine square theta plus 2 sine theta cos theta plus cos square theta. I just switch the order. Everywhere is addition, I can switch the order. So now on the bottom, if I think that sine is my a, I have a square plus 2a, and I think cos is b, and then I have plus b square. A square plus 2ab plus b squared is nothing else but a plus b and square it. So what we have on the top, I still have these two brackets, cos theta minus sine theta, and then we have cos theta plus sine theta. And on the bottom I have nothing else but a, which is my sine theta, and b is my cos theta, and square it. And now the brackets cancel out. Cos plus sine is sine plus cos is the same. So this bracket and this square cancel out. And what I'm left with is cos theta minus sine theta over sine plus cos, which I'm gonna rewrite as sine plus cos. So now I need to get cotangent. How can I get cotangent? And minus 1. So I'm gonna divide or multiply times 1 over sine theta. I'm gonna multiply sine theta, everything. So I can get 1 on the other side. What I'm doing on the top, I need to do on the bottom as well. So in other words, each and every term I divide by sine theta. So what we are getting cos theta over sine theta minus sine theta over sine theta, and all over sine theta over sine theta plus cos theta over sine theta. Sine theta gives me 1, and cos over sine is nothing else but cotangent. So this is equal to cotangent theta, sine cancel out, minus 1, sine cancel out, 1 plus cos over sine is cotangent. So the bottom we can rearrange, and we are getting what we need. Cotangent theta minus 1 over cotangent theta plus 1, which is equal to the right side, and that completes the proof.